Hi everyone, I'm Lavanya from final year BME. I'm here to discuss about the topic PET imaging for early cancer detection. The objective of this topic is to analyze the working principle, mechanism, and scanner design and clinical application of PET imaging. The introduction part is past, first of all, the full form of PET is positron emission tomography, which is a powerful nuclear imaging tool. It provides the information about the tissues. Unlike CT or MRI, which shows only the anatomy of the tissues, while we using the PET imaging, it shows the biochemical activity of the tissues. A commonly used radiopharmaceutical in oncology, which is fluorodeoxyglucose, labeled with fluorinating. The principle of PET imaging was the positron is emitted by a radioisotope and it meets an electron. Then it producing the two 511 kilo electron volt gamma photons. That photons are emitted from minus 180 degree apart from the tissues or object. PET scanner it detects the coincident photons. That photons reconstructed 3D images of metabolic activity in computer. Radiopharmaceutical used. The fluorodeoxyglucose is a glucose. It was the analog labeled with positron emitting isotope fluorine 18. It also has the beta plus emission and production of cyclotron, etc. The mechanism of FDG. The FDG enters to the cell and through the glucose transporters. That transporters phosphorylated by exokinase to FDG6 phosphates. That FDG6 phosphates get only trapped, not further metabolized. And it is accumulated in cells with a high glycolysis. Example, cancer. It enables the visualization of tumors on PET images. The PET scanner design. A modern PET scanner consists of detector ring, coincident circuits, data system, and PET or CT. The first one is detector ring. The detector ring was scintillate the crystals to detect the gamma photons and converted by PTMs or SIPMs. Coincident circuits. It detects the simultaneous photon pairs and filter out the noises. And third one is data system. It records the signals to create the detailed image of PET. Last one is PET or CT. It combines the metabolic and anatomical data for precise tumor or cancer detection. That's all about my topic. Thank you.
Hi, I am Niveta from final year biomedical engineering. I am here to share about the PET imaging for early cancer detection. In this presentation, I am covering the topics of imaging procedure, image interpretation, and the clinical applications in oncology, advantages, limitations, and radiation safety and dose, and also the conclusion. Now, we see about the image procedure. Patient fast for 6 hours to reduce background glucose levels, and the intravenous injections of 18F FDG and the rest period for radiopharmaceutical uptake. The whole body PET scan is performed in 20 to 30 minutes. Image reconstructed and analyzed by the nuclear medicine specialist, and then the image interpretation. Hypermetabolic regions indicate potential malignancy. The standardized uptake value is used to quantify uptake intensity. The standardized uptake value is greater than 2.5, often suggests malignant activity. Low uptake areas may indicate necrotic or benign tissues. Now, let's see about the advantages of the PET. The PET detects cancer before anatomical changes appear. Provides whole body metabolic imaging in one scan. Useful for therapy monitoring and prognosis evaluation. Next, the high sensitivity and specificity for malignancy. The limitations are high cost and limited availability of cyclotron produced isotopes, false positions in inflammatory or infectious lesions. Then limited spatial resolution compared to CT and MRI. Then the radiation safety and dose. Typical effective dose is 7 to 10 milli MSV per FDG PET scan, and then the ALA-RA principles are followed. Then the patient is advised to close contact with the other for few hours of post scan. Then the clinical applications in oncology. FDG-PET is widely used for early detection and primary tumors. The staging and assessment of metabolism. Monitoring treatment response. Then the detection of tumor recurrency after therapy. The common cancers evaluated like lung, breast, and then the head and neck cancers. Finally, the conclusion is the FDG PET imaging is critical role in model oncology by enabling functionalized visualization of cancer metabolism. Through the combination of positron emitting isotopes, advanced detector systems, and imaging reconstructing algorithms, PET scans provide unparalleled diagnostic accuracy for early cancer detection, staging, and therapy monitoring. Thanks. Thank you for this opportunity.